So today we're discussing navigation, and you're going to be using navigation when you do your project on the Bermuda Triangle that you all are going to start today in class. So first thing, all year long we've been talking about angles, and we've been talking about angles in standard position. And we talk about them in standard position so that everybody can kind of think about them in the same way. So why are angles always in standard position? So everybody pictures that same image. So for example, if I say draw 30 degrees in standard position. Well, you guys all know standard position means your initial side is on the positive x-axis, your terminal side goes counterclockwise, and that this right here would be 30 degrees. Okay. Well, today we're going to be talking about angles in a couple different ways. In the transportation world, mostly ships and airplanes, angles are told in different ways. So we're going to look at standard position, which we already talked about, and then something called a bearing and something called a heading. Okay. So standard position is measured by placing the initial side on the positive x-axis. So that's what we did here. That's my initial side on the positive x-axis, which is east if you're thinking north, south, east, west. Then you go counterclockwise for the positive angle measurement. So this measure angle up here, the top, right? Notice that we moved counterclockwise, up, okay? That's counterclockwise. 30 degrees to get that angle. And that's a positive angle measurement. If we went clockwise, went down here, that would be a negative 30 degrees, and you guys should all know that. Positive angles go this way, negative angles go this way when they're in standard position. Okay? So that's standard position. Now, a navigational heading. So navigational heading is measured by placing the initial side on the positive y-axis, so north. Okay, so if you're thinking about, I'll draw it in here real quick. Here is north up at the top. Okay. So you're placing the initial side here and you're moving clockwise for a positive angle measurement. So if I say you're traveling on a heading of 30 degrees, now what that means is that from north, I have to think about 30 degrees out, and that means I'm heading in this direction. Okay, so that's a heading of 30 degrees. So you start from north and you move clockwise for your positive angle. Now, navigational bearing. If I give you a direction in bearing, it's measured by placing the initial side on either the positive y-axis, which is north, or the negative y-axis, which is south, and then moving either clockwise or counterclockwise, whichever is the shorter distance. So you're going to see your angle written as north-south or east-west, etc. So let's look at some examples so you can see get a better idea of navigational bearing. All right. So let's start out here. So I have this 30-degree angle. Now this is 30 degrees from the positive x-axis. So what I want to know is, what is that angle measurement in standard position? Well, in standard position, we would say that's 30 degrees. Now, I want to know it as a bearing. Well, remember, bearing means you think about it as from north, and then you travel clockwise. So knowing that this is 90 degrees, this would be a 60-degree angle in here. So your heading would be 60 degrees. Now your bearing, remember your bearing is always going to start at north or south, whichever it is closer to, and then it's going to go either east or west, whichever is closer. So here you say we're at a bearing of north, 60 degrees east. So we're starting at north, which is up here at the top, and then you're going 60 degrees east, this direction. If I had said north 60 degrees west, then I would have ended up over here to the left. So this angle here would have been north 60 degrees west. Okay? All right, let's look at another one here. So you probably already saw the answers, but pretend you didn't. So we've got this negative 45 degree angle. So let's start out with standard position. In standard position, you measure this from the positive x-axis, and then we're going to go clockwise or counterclockwise for our positive angle. So if that's negative 45, standard position or positive angle will go this way, and that's 315 degrees. Okay? As a heading, remember that you start out north and then you go clockwise. So I want to know how many degrees do I travel on my heading. Well, this is 90 degrees on top, plus 45 would mean that I'm on a heading of 135 degrees. Okay? As a bearing, remember it's north and then an angle and then east or west, or south and then an angle and then east or west, depending on what you're closer to. So for this example, this angle is closer to south. So we're going to start out with south, and then you have to travel east. Okay, how many degrees do you have to travel east to get to this directional arrow here? Well, 45 degrees. So you're going south, 45 degrees east. Okay, south 45 degrees east. That's your bearing. So heading starts at north, bearing starts either north or south, and then goes either east or west from there. Okay, two more examples. This guy here, as in standard position, positive x-axis. Think about what your angle is here. If that's 70 degrees, this must be 110. So you're going 110 degrees if it's in standard position. Next, think about your heading. Remember, your heading starts at north and then travels clockwise. So here's north, then we're traveling clockwise all the way around, and you got to think how many degrees would that be? Well, it's 270 plus 70, so you get 340 degrees is your heading. Now, thinking about bearing, it's either north-south and then east or west, so you pick the one that it's closest to. So as a bearing, closer to north, and then it travels west. And how many degrees does it travel west? Well, 10 degrees. So this should be 20 degrees. North, 20 degrees west, because this would be 20 degrees in here. Okay, last example. You have this straight line. In standard position, this is 180 degrees. So there's 180 degrees. As a heading, remember you start at north and then you travel clockwise. So you're traveling 270 degrees. So as a heading, you would say 270. And as a bearing, you would say north, 90 degrees west. You could also call this south, 90 degrees west. It would be the same exact thing. Okay, so that's standard position, headings, and bearings. Now let's look at one example of how you set up a problem. So in this example, two ships leave port at the same time, one sailing in direction north 23 degrees east at a speed of 11 miles per hour. Second ship in the direction south 67 degrees east at 15 miles per hour. After 2 hours, find blah, 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 that information. So let's draw the picture. So I want to start out thinking about north 23 degrees east. Okay, so I'm going to think about this starting point here, north 23 degrees east, it's going to put this ship going in this direction. Now the second ship is traveling in the direction south 67 degrees east. So I'm starting south and then we're going 67 degrees east. So it has it traveling in this direction. Now the first ship is going 11 miles per hour and the second ship is going 15 miles per hour. So I want to know after 2 hours, that means 11 times 2 is 22 miles. So we've gone 22 miles. And down here, we've traveled 15 times 2, so 30 miles. I want to find the distance between the two ships. So basically, it's asking you to solve for this side of the triangle. And I'll leave that for you guys to do. Over here, the answer is obviously already there. And you guys can check the answer key. But this actually ends up being a right triangle. If you figure out this angle here, you could do the Pythagorean theorem. And then the bearing from the southern ship to the northern ship. So here's the southern ship. If I draw in my axes, making sure to make them north, south, and east, west, I want to find the bearing, which basically means I need to find this angle down here. I know that I'm going north and then west, but I want to know for how many degrees. So to figure that out, you need to determine all of the angles inside of this triangle. And then everything else should kind of fall into place. So I'll let you guys figure that out. And you can try the rest of the problems. The answer key is posted online.